Whenever we're asked to factor anything, we always want to check for a GCF first. So looking at this first polynomial that I'm asked to factor, I would actually look for among these, I have 4 separate terms. Is there something that all 4 of them have in common? And it's very close here. So actually, other than the first term, the rest of them I could actually factor out a 2, right? The first 2 terms I could factor out an x. On these 2 terms, I could factor out a y. But there's actually not any GCF in all 4 of these terms. So I would always check that first, but in this case, I can't factor out a GCF. So this one says to factor the polynomial using the grouping method. So that's the method we're going to go through here. But if your instructions didn't specify a method, if they didn't say to use grouping, then usually you know to use grouping if it's got 4 terms. So check a GCF first, but if it's got 4 terms, usually grouping's the way to go. So the way that the grouping method works is it says, okay, so there's not a GCF in all 4. Can I group my first 2 together though, and group my second 2 terms together and look for a GCF in each group? So if I just focus on that first group, 15xy plus 20x, on those 2 there is a GCF. The GCF there would actually be 5x. And so I'm going to go ahead and factor the 5x out of that first group. 15xy divided by 5x would leave me with 3y. And 20x divided by 5x would be positive 4. And then this is the part that's easy to forget, but when you're doing factoring by grouping, whatever the sign is in the middle of your 2 groups, you need to bring that down. And then I'm going to factor out a GCF out of my second group. So in 6y plus 8, there's actually a GCF of 2. And so I would divide both of those terms by 2. 6y divided by 2 would be 3y. 8 divided by 2 would be positive 4. And I'm not finished, but at this point, I can always check and see if 1, if I'm on the right track, and 2, is grouping working by, do I have the same thing in both parentheses? So if I've got the same thing in each parentheses, I know that what I'm doing so far is correct and that the grouping method is going to work. If you, at this step, discover that your parentheses aren't the same, double check and see, did you make a small like sign error or calculation error, especially if they're close to being the same. But then if that doesn't work, then probably the grouping method's just not going to work on that problem. Usually if it's got 4 terms and they're asking you to factor, grouping's going to work. So you're going to have matching parentheses. And then this goes back to some problems that we did when we did GCF method. So really, I'm just looking at this now as a whole again and saying, what do they have in common? Well, actually, this half and this half both have a 3y plus 4 in common. So I'm going to go ahead and factor out the 3y plus 4 as my GCF, and then I'm going to write what's left in parentheses when I factor that out. So if I take this first half and divide it by 3y plus 4, the 3y plus 4 cancels and leaves me with 5x. If I take this second half and divide it by 3y plus 4, the 3y plus 4 cancels and leaves me with positive 2. And that is my factored answer. So factoring by grouping is typically going to have one step where you're showing work, and then you go to the answer. And I'm going to do this at least once just to show that you can. So let's just check my answer. So all factoring problems, you can do this. So if I want to check this, what I would do is, you might have learned it as the FOIL method, which stands for first, outer, inner, last, or basically multiply every term in the first parentheses times every term in the second. So I'm going to start by doing 3y times 5x, which would be 15xy. And 3y times 2 would be positive 6y. And then I'm going to take, so I did 3y times everything in the second parentheses, so let me take 4 times everything in the second parentheses. So 4 times 5x would be 20x, and 4 times 2 would be 8. And then just check and see, yep, sure enough, that matches exactly what I started with, so I know that that's factored correctly. So you can always check your work. And I'll admit I don't always do that, but on a test I do. So it's worth your time to actually check your answer and make sure you're getting back to what you started. So let's do another example. So again, I would look for a GCF in all 4 terms. This one, again, it's close. 2 would go into everything except for the 5y. The first 3 terms all have x's in common, but the 5y doesn't, right? So there's no GCF in all 4 terms, so I'm going to use grouping. I'm going to group the first 2 terms together and the last 2 terms together and look for a GCF in each. So between 4x squared and 2xy, the GCF is 2x. 4x squared divided by 2x would be 2x. And then 2xy divided by 2x would just be positive y. Make sure you bring down the sign in between your 2 groups, in this case, that minus sign. And then the GCF between 10x and 5y would be 5. Now, technically, because I brought down the negative, technically that means my GCF is negative 5. So if I take negative 10x and divide it by negative 5, that's going to leave me with positive 2x. And then negative 5y divided by negative 5 would be positive y. And I know that I've done it correctly and that grouping is working because I've got the same thing in each parenthesis. So I would just take that part that they have in common and factor it out front. And then you could just cover that up basically to see what's left. And so in this case, what's left when I factor that out is 2x minus 5. So let's go to the next one. So there's not a GCF in all 4. It's close, but that last one doesn't have an x. So I'm going to group my first half and my second half together. In my first group here, the GCF is actually x squared. And so I would factor that out. X cubed divided by x squared would be x. Negative 2x squared divided by x squared would be negative 2. I'm going to bring down my minus sign in between the 2 groups and factor out a 3. Although technically, since I brought down the negative, I'm factoring out a negative 3. So negative 3x divided by negative 3 is positive x. And then 6 divided by negative 3 would be negative 2. And so if you discovered at this point that one of them says x minus 2 and the other says x plus 2, go back and check your work. But in this case, I know I've done it correctly because I've got the same thing in both parentheses, x minus 2. If I factor that out, that leaves me with x squared minus 3. And then let's do this one. So there's not a GCF in all 4 terms. So let's factor out, in this case, I can factor out a 5x from my first group, which would leave me with 4y minus 3. And then I'm going to bring down my negative sign. And then I'm looking for a GCF in my second group. And my second group here is 4y and 3. And you might say that there's not a GCF there. There doesn't seem to be anything in common. Actually, what we say, though, when that happens is we say the GCF is 1. And so I'm going to go ahead and write that 1 down. And technically, again, since I brought down the negative sign there, the minus sign, that means my GCF is actually negative 1. So I'm going to take both of these terms and divide them by negative 1. So negative 4y divided by negative 1 would be positive 4y. Positive 3 divided by negative 1 would be negative 3. And I've done it correctly because I've got the same thing, 4y minus 3, in each of those 2 parentheses. When I factor that out, that leaves me with 5x minus 1.